This is video 44 on MicroPython and LVGL 9.4 on a standard Pico USB board. LVGL 9.3 was released 3 June 2025. This means dev LVGL 9.4 is now the latest source in GitHub. To work with the latest, we built firmware for all 4 standard Pico boards. In the online doc, we noticed an auxiliary module titled Observer. For this video, we investigate it. Please let us know in the comments if you like this example, or let us know if you have suggestions to improve it. For this effort, a test rig for each Pico board was flashed with the corresponding firmware and connected to an ILI 9341 display. After a brief functionality check, we are ready. As this channel covers multiple small system solutions over time, please subscribe to stay informed and click like, as that really helps. Our goal for this effort is to experience LVGL 9.4 and learn about subjects and observers. We will discuss the latest LVGL 9.4 software and the firmware, present the test rig configuration, discuss the observer module, demonstrate an observer module example using a code example that we migrated from the user documentation, and review the code. The program files are at the GitHub site that is mentioned in the description and endnotes for this video. After the LVGL 9.3 software was released in June, there are significant changes to the online documentation. A new feature is introduced called XML Declarative UI, and there were many small features and fixes added. Fetching the latest LVGL source now gives us Development 9.4.0 software. The new firmware includes the latest MicroPython and ulab. So our GitHub site contains new firmware for all 4 standard Pico USB boards. The next 3 slides summarize the test rig hardware wiring. Most of the configuration is defined in the files called display_driver and the SD card_driver. This video's example does not need the SD card driver, but it's included here for completeness. Notice that the ILI 9341 display and touch use SPI 0 and the SDR card, and the SD card uses SPI 1. This picture of a Pico demonstrates where the SPI pins are located. This list summarizes the most common driver files located on the Pico's flash drive. In case your test rig is wired differently, you may need to edit the pin numbers for the display driver and the SD card driver files. Now that we have our test rigs, let's investigate the observer module. The observer module implements subjects and observers. We begin by discussing subjects. A subject is an LVGL structure that holds a global value. The subject, when defined, is accessible to our MicroPython application code and to the user interface of our LVGL widgets. A subject is defined with a specific data type, like an int or string or color, and can be initialized. A subject can be bound to an LVGL widget, and this is demonstrated soon. The observer module is an implementation of observer pattern. The term observer pattern can be researched further by doing an internet search. An observer subscribes to an LVGL subject. It observes the subject's value, and any value change invokes your callback routine. I roughly depict the interaction. Here, our application code initializes the value of a subject. LVGL widget A is bound to the subject, which automatically updates the subject's value. Meanwhile, an observer was defined that is watching the subject's value. Any change causes the observer to invoke the callback routine. The routine can do anything, including an action to some other LVGL widget, here called LVGL widget B. Let's look at a demonstration of test_slider_display. I already have the program running in the screen. The screen shows an LVGL slider, or widget A, and an LVGL label, the other widget. In the code, a subject called subject1 is defined and initialized with integer 10. So here, subject1 is defined and it's initialized with the integer value of 10. Next, we define an LVGL slider widget, and it is bound to subject. So here's the slider 1 that we defined, and here we bind it to subject 1. Next, we define the LVGL label widget, called label 1. This will be updated by the callback. Now we define a callback. We'll come back to this. Finally, we define the observer. There are 3 ways to define an observer, but I'm showing you the most useful, which is to define the observer with a widget object. We provide the callback, the widget object, here it's label 1, and the user data, which is always none. The callback expects to receive an observer and a subject. Now, similar to an event callback, we get the observer's object, which we know to be a label. Finally, we update the label's text using the current subject's value. Since the slider is bound to the subject, let's increase the slider's value by touching the handle of the slider. Notice that the label's text is updated immediately with the new value. All right, it's working great. In summary, in this video, we introduced the LVGL 9.4 software and the firmware on Pico. We discussed the observer module, we demonstrated an example of an observer, and reviewed the code. The benefit is simple and more flexible code. And when an observer and its associated events are no longer needed, you can remove it from memory. Hopefully, you have a better understanding of subjects and observers. Please comment if you feel other changes are needed. I hope this video helps your LVGL MicroPython coding. Thank you for listening.